It's exponents, truth, and graphing. So we will be exploring square roots and cube roots, how to use our calculators to get the square roots, cube roots. So you should have your TI-84 out. So first, just for square roots and cube roots, we're just going to explore what they are. So the first thing we want to do is to look at what is a perfect square. So it's a number that's found by squaring another number. So basically, you're raising a number to the second power. That's like saying number times a number. Not just any number, it's the same number twice. So that's a perfect square. 2 times 2 equals 4. And just recall, we don't use the x anymore for multiplication. For the perfect cube, it's a number that's found by cubing a number, raising a number to the third power. So I could have x cubed, and that equals x times x times x. I could also say 4 cubed. That equals 4 times 4 times 4. The only difference is between using numerals and variables is that the numerals produce actual numbers. They produce actual numbers and not just the variable term. So 4 times 4 times 4 produces 64. Okay? Now the inverse of a perfect cube, perfect square, is a square root. So the opposite of saying x squared is the square root of x squared. That's like saying the square root of x times x. And what it's asking is, how many pairs of x's do I have inside of the radical? Well, I have 1 pair. So 1 comes out and 1 goes away. For the cube root, it's asking how many triples? How many triples? Make that a little bit neater for you. Make that a little bit neater for you. Okay? Yeah. So for the triples, I'm just going to write it above. It looks like this. It's the radical symbol. The only difference is there's a little 3 inside, and you have the x cubed, right? So how many triples? You have 1 triple. So what comes out is just 1 of the variable terms. Okay? Now below, you're going to complete this table. I'm going to show you how to complete the table. This below, we're going to do these squares here. Okay? So for the factors, you're going to write 1 squared is 1 times 1. This equals 1. Okay? 2 times 2 equals 4. So you're going to go through, complete the whole table. When you get to the cubes, you're going to have 1 times 1 times 1. That's 3 ones equals 1. 2 times 2 times 2 equals 8. So complete the whole table. And when you're done, you'll basically, the result, like the purpose of this is to get practice. You want to get practice using the factors, understanding the factors and how they work with powers, how they're the same. It's how the powers, using powers is notation, abbreviated notation for factoring. All right. Now, after you're done, you can pause the video, or you could come back and do it, one or the other. But we're going to move on to how do I use my graphing calculator to find a number raised to a power. So had I wanted to find 10 squared, I would press clear to clear out my calculator. If it's in a screen like y equals, or window or anything else and it's not clear, you just press second mode and it's clear. At 10 squared, I can press 10 x squared, enter, or I could press 10 up arrow 2, enter. If you want to see the keys that I use, I can show you. So it's 10 x squared, or it's 10 up arrow 2. If I wanted to find cubes, I could say 10 up arrow 3. But next, we're going to go over how to find square roots and cube roots. Here's history. So here, both equaled 100 when we were raising 10 to the second power. Now, how do I use my graphing calculator to find a square root? Notice that the square root symbol on the graphing calculator is in blue. It's in blue. And it's above the x squared key. So we're going to press second in blue. And then we're going to press x squared to get that square root symbol. And then we're going to write the numbers inside, and we're going to find a square root of each of those numbers. So go back to my calculator, press second x squared, 576. Make sure you're completely inside of that radical. Press enter, and you get 24. So 24. Now for the next one, I have 961. So second square root 961. Enter, and you get 31. For the last one, I have second x squared 21025. 21025. Enter. And I get 145. Okay? Now, what about the cube root? It's right below. Cube root's simpler. You're going to go, well, actually, it's not, but you're going to press math number 4. Math number 4. And you get the cube root. Put my first number in. I get 1,331. Enter, and I get 11. It equals 11. If you keep going for the cube root of 3,375, you get 15. For the cube root of 27,000, you get 30. So just in summary, raising a number to the second power is the same as multiplying it twice. Square roots are inverse operations. Cubing a number, multiplying it by itself 3 times. And the cube root is taking the inverse of that cube, that perfect cube. Okay? So the next section is going to be truth values. So when we're proving equality is true, we do it by evaluating or substituting with what is given. In other words, you can prove that a number is a solution by substituting in the equation, and each side equals the other side. So if 1 equals 1, so here 1 equals 1. So we're going to write true or false below the statement that is given, and then we're going to provide a counterexample. 1 equals 1. It's true. You don't have to write out the statement, but it is true. But 2 equals 0. Is that true or false? It's false. Is 2 less than 10? Yeah, that's true. Is 2 less than -4? No, it's false. So for the ones that are false, we're going to create counterexamples. So 2 actually equals 2. These are facts. And 0 actually equals 0. They don't equal each other. And here, what's false? 2 is actually greater than -4. It's an opportunity to check on our knowledge regarding greater than and less than symbols. Okay? When we're checking the truth of equations, we do it, typically you're substituting back into the expression, and you're going to check the truth of the statement. And the way you start, you put a question mark above the equal sign, okay? And we're going to substitute in 9 minus 4 equals negative 8. Does 9 minus 4 equal negative 8? That's the question we're asking. Well, 9 minus 4 equals 5. And we find that it's not true. So you put a slash down the equal sign. We write false. We write false. This is not true because we check our statement. We've shown that 9 minus 4 actually equals 5. We've already done all the work we need for the counter example. For the next one, we have 1/2 times x minus 2 equals 18 when x equals 40. So we just substitute in 40. We replace the x with 40. Don't forget to use the parentheses. 1/2 times 40 is 20. Minus 2 equals 18. 20 minus 2 equals 18. 18 equals 18. So this is true. This is true. Below we have 3x minus 4 equals negative 28. So 3 times negative 8 minus 4 equals negative 28. 3 times negative 8 is negative 24. Minus 4 equals negative 28. And we end up with negative 28 equals negative 28. So both of these make the statement true, make the original statement true. Checking with the cube root, okay? You guys are pretty smart so far. So let's cube root that. Put a 2 times x. My x here is 3, so I replace the x with 3 plus 2 equals 4. Cube root of 2 times 3, 6 plus 2 inside equals 4. And I end up with the cube root of 8 equals 4. And if you put it in your calculator, which I want to do with you, so math, number 4, cube root of 8, enter, and I get 2. I get 2. 2 does not equal 4. So this is false. This is false. Okay? I can check the truth of a statement by replacing the variable okay, into the original equation. That's what we just did. We checked the truth by replacing a variable into the original equation. The next page, we're going to explore graphing points. Okay? So on the coordinate plane, a two-dimensional figure always maps left to the right. And we're going to have one more up and down. Okay? And the coordinates, x and y. And typically we use the ordered pair in the form of x, make sure you include your parentheses, comma y. So the x values, these are things, concepts you already know. We're building your language skills so you're better at algebra as we move forward. Is always first. The x values, they're always first. And x value is the domain of the coordinate. So x values move only to the left and only to the right. Whereas y values are always second in that ordered pair, and it's the range. Y values move up or above the origin, or they move below. Okay? So the point where x equals 0 and y equals 0, this is the origin. It's the ordered pair 0, 0. This is the origin. On the first map, the origin is located here. So we draw an arrow, put in the coordinates, also write origin. I wrote it upside down. You can too. You can be creative. Here, I'll write it right side up. Right? So, origin. Second map, I refer to as maps and graphs interchangeably. The origins in the center. Let me move that over. Let me move that over. Okay. Origins in the center. Draw a little arrow, say origin. I write origin. I write that these coordinates are called 0, 0. And then I scroll down. Given the points below, we're going to label the points, identify the direction. We'll have to move on the graph and then graph the points. So we're going to be graphing points in the next section. And I think this is going to be, so far so good, pretty easy through all classes. So first, label the points, and we're going to need these skills when we do Unit 4. Okay? Label the points, and then we just explored the direction that X values move. They move left and right. Range moves up and down. So if it's positive, 1, we're going to move right 1 unit and then down 4. Right 1, down 4, make a point. This is point A. Good. For B, I'm going to move right 3, up 5, right 3, up 5. This is point B. For C, we're going to move right 2, and that's it. So, sorry, not right 2. We don't move left or right. We move only up, right? So you gotta watch. We move only up, and I forgot to label my points. I want to make sure we do that. That's important. So we only move up 2, right? And we label it C. Okay. For B, move left, up 3, left 4, up 3. Make a point, put D. For E, move left 3, don't move up or down. And that's E. So far, so good. And then left 2, down 5. Left 2, down 5. And that's F. Okay? And that's all I have for you. The last part of this unit is going to consist of the unit review. I hope that you know how to use your notes to start that unit review. Do the homework in your packet. It's going to be page 6 and 7, I believe. Have a good day.